Hello everyone, in this video we're going to be discussing section 14.6, apply sum and difference formulas, which begins on page 949. Now, I would say go ahead, write these formulas down in your notebook so that you have them, but for your quizzes and homework and everything, you can go ahead and reference back to this page, so I'd put a little bookmark in there so that you can use it. Typically speaking, when you're moving on to pre-cal and calculus, eventually you'll get to a point where you've used these so much that you will have them memorized. But for now, you'd be getting a sheet with these formulas on it. So, in this lesson, we are going to be using these different trig functions of the sum and difference of two different angles. So, that's the A and the B here are two different angles. Alright, and we can use that to figure out an actual value. So for example, if I had one angle that was 37 degrees and another angle that was 82 degrees, right off the bat, to find an exact value, I wouldn't know what the sine of, 37 degrees is. It's not one of those special angles. And I wouldn't know what the sine of 82 is without using my calculator. However, I'd, be able to somehow put those together using a sum or difference. 82 minus 37 does equal 45. So I'd be using those special values, sine and cosine of 45 degrees being radical 2 over 2. So that's just a mini example of something we'd be able to do. Alright, so this is just all about recognizing whether you have sines and cosines and whether things are being added or subtracted and the different values. So it's just all about recognizing what equation is it going to fit. So we have 6 different ones listed here. Obviously sum is going to be adding two angles together. So if you know like the sine of 30 plus the sine of 30 plus 60, that's going to equal the sine of 90. If you don't know what the sine of 90 is, you could break that apart into 30 plus 60. And then differences, I'm going to be subtracting. So as you might be able to figure out, with the different formulas, there are some consistencies and some inconsistencies with just, how they're set up. Alright, so some signs switch, but overall the format is the same, other than the signs. Alright, so example 1, find the exact value of the sine of 15 degrees for part A. So, I don't know what the sine of 15 degrees is, but I know that 15 is 60 minus 45. So I go ahead and substitute that in there. So that is going to be a difference formula. So I go ahead and write out my difference formula, substituting in the values for 60 for A and 45 for B here. And then I can use the chart on page 853. Alright, that chart has the sine, cosine, tangent of your 30, 45, and 60 degree angles, those exact. Alright, so all I need to do is use a whole bunch of parentheses, which I would put parentheses around every single one of these, and then multiply and subtract. Alright, when I multiply, radical 3 times radical 2 is a radical 6, and then radical 2 times 1 is just radical 2. Alright, and then in the denominator, they do end up with a common denominator, which is fantastic. If they don't, then you would have to find a common denominator. So this is my exact answer, and then I can type it into a calculator and get an approximate answer. If I do, that would, be accompanied by an approximate sign here, but I wanted exact, and we found exact. So radical 6 minus radical 2 divided by 4. Alright, so part B here, they're asking for 7 pi over 12, so that is signaling to me that when I go to my, little table on page 853 there, it's going to be helpful to relate 30, 45, and 60. 30 degrees is pi, or that 180 degrees divided by 6. 45 is pi divided by 4. And 60 degrees is pi divided by 3. So if we see this common denominator of 12, we might recognize that I'm going to need to be using these values, alright, the pi over 4 and the pi over 3. Alright, so tangent of 7 pi divided by 12 is the same as tangent of pi over 3 plus pi over 4. So then I can use a sum formula, which this gets a little bit funky with all the different pieces, but substituting the values incorrectly into that equation, and then computing those from that table. I have the tangent of pi over 3 is radical 3, tangent of pi over 4 is 1, and so the numerator is radical 3 plus 1. And then my denominator comes out to 1 minus radical 3 times 1, so that's 1 minus radical 3. And what they do to simplify this, this is radical 3 plus 1, which the numerator, for the record, that's the same as 1 plus radical 3. And then in the denominator, I get 1 minus radical 3. And we do not like radicals in the denominator, so I need to multiply by our conjugate, which is 1 plus radical 3 over 1 plus radical 3. Alright, so I then need to FOIL that out, and that is how they get this mess. Alright, that is our exact answer. They skip those steps and they don't tell you what to do, but don't forget to multiply by your conjugate if you see a radical in the denominator. And FOIL out if necessary. So in this problem, that foiling is necessary. Alright, here in example 2, we want to find the cosine of a minus b, where the cosine of a is negative 4/5, and the sine of b is 5/13. Alright, and we do have some restrictions here on our a and b values as far as our inputs and what we're allowing here. So that's just going to give us a couple of restrictions on the outputs as well. Alright, so solution. Use the Pythagorean identity and the quadrant signs to also figure out what the sine of A is and the cosine of B. So there's a decent amount of work that goes into this step where they're not actually, showing you step by step what's going on. So for cosine to come out negative, I'm just going to work on this for a second. For cosine to come out negative, using my quadrant signs, all students take calculus. Alright, cosine comes out negative in the tangent here and the sine quadrant here because it is positive in the first and the fourth. So 4 negative 4/5, so I know that if the cosine of A is to come out negative, it needs to be in quadrant 2 and quadrant 3. So if I were to draw this out a little bit, that negative 4/5 kind of tells me go left 1, 2, 3, 4, and then my hypotenuse is going to be somewhere above that. Alright, so my hypotenuse is always positive. Alright, so this is a distance of 4. Alright, if this is my angle A, alright, this could also be angle A. I'll just do A1 and A2, where this is 4, and then our hypotenuse is 5. Now, if you see these two triangles, you would have to know that this is 3. Since it is a 3, 4, 5 right triangle, a Pythagorean triple, you could also use the Pythagorean theorem to figure out what that third side of the triangle is. Alright, so I use that 4/5 to kind of draw out the side adjacent and the hypotenuse, and then I draw the triangle. Alright, so the sine of A here would be the side opposite over hypotenuse, keeping in mind that we actually did have a domain restriction. So let's go ahead and go back to the domain restriction before we concrete our answer and write 3/5. Alright, so it said it's between pi and 3/2 pi. So that means I'm actually only talking about this third quadrant. Alright, so in this case, my third side here is actually going to be a value of 3 again. Sorry, I wrote a -3 in there. Alright, it's still 3. The length is 3, but it is in that third quadrant. So if I were to talk about sine in the third quadrant, it's going to come out negative because that's the tangent. All students take calculus, so the tangent would be positive, but sine would end up negative. So that's how they get -3/5. And quickly going through B here, I'm going to go ahead and draw my triangle. It's telling me that I'm going to be between 0 and pi over 2, which means I am going to fall in this first quadrant. So if I look at that restriction right away, it's going to save me a little bit of pain. So here is, some angle B. Here is angle B. And it tells me that the sine, which is the opposite, 5, over the hypotenuse, 13. Alright, so I can then use my Pythagorean theorem to find my third side, which I would get 12. So to figure out cosine of B, it would be 12 on the adjacent side over the hypotenuse, 13. Alright, so I need the sine and cosine of A and B in order to use these formulas, alright? That's why we're having to, use this whole triangle idea, as well as our signs, our quadrant signs. So just confirming here, this is the first quadrant, the A, the all quadrant, so all of the trig functions are going to be positive, alright? So that's true there. So, moving forward with all that, I can use the difference formula for cosine. So, now that I have cosine of A, cosine of B, plus the sine of A, plus the sine of B, I substitute in my values. Alright, and I would be careful and use parentheses for all of them. So when I multiply through, -4 times 12 is -48. And then 5 times 13, I have 5 times 10, 50, plus 5 times 3, 15, so it's 65. And that ends up being minus 15 over 65. Alright, which gives me -63/65. Okay, so here's a couple of guided practice. I would go ahead and think about, what angles could I possibly be adding or subtracting to get 105 degrees. Alright, pause the video, see if you can work that out and get the exact solution. Alright, with this 5 pi over 12, I would consider the denominators 3 and 4, so a pi over 3, pi over 4 somewhere, making sure that those add up properly or subtract properly to get that 5 pi. Alright, so we're going to go ahead and chop off this video here. We're going to save example for 14.6 continued in the next video. If you guys have any questions whatsoever, or you want to, contact me during office hours, please feel free to do so. I'd be more than happy to help you guys out with any questions. Alright, good luck.